Yep.
Hey everyone, welcome back to Self to Self. My name is Heem, that's Nick, and today we are going to be doing a react on a TED Talk about 3D printing organs. Now, Nick, do you know anything about this?
The one thing I do know is that if you're watching this, you should hit the subscribe button and the like button and comment on our videos and keep watching and supporting us. We appreciate you guys. We've seen the support over the last couple of weeks, and we just want to say thank you. And to all our new subscribers, welcome. But when it comes to 3D printing, subscribers, no. Organs, yes. So I know there was a guy at Case who was 3D printing kidneys for like a little bit and for people who were on like dialysis and stuff. But basically, 3D printing organs would is just taking a polymer, like something flesh-like, or cells, or your honestly, I don't know.
Okay,
I'm
yeah,
trying to
I
talk my way
mean,
around it, but like I'm thinking of like scaffolding and growing cellular matrices on like a plate to then form into like a joint or like a ligament, but I can't tell you like, oh, this is how you would print a kidney.
now the thing with this, it makes me think is like, so 3D printing, like normally plastic and stuff, they heat it up to like super high temperatures so it melts, and then the thing goes, and then as soon as it touches it, it cools down so it hardens and stuff. But with this, if you're 3D printing cells and if you're using stem cells, I feel like your nozzle should have your stem cells, and then there should be another thing that's like giving uh growth factors or something that's differentiating those stem cells to the particular lineage they need to go to. So if you're 3D printing a heart, there has to be some majority muscle, but then some fat, a lot of nerves,
Right.
and all these things that you have to like. It's super complicated and complex, but yeah, I'm excited to learn about this because it's a TED
Yeah.
Talk and it's a TEDx Ed, so it's like
Yeah.
super
So
educational, but
it's going to be really, really cool. So let's
yeah.
go ahead. I'll share my
Nick's
screen.
gonna share his screen and then can you make sure that it the voice comes the noise?
It should.
Okay, just try.
Can you hear him?
I cannot know.
Oh, Lord. 1 second.
There are currently hundreds of thousands of people on transplant lists, waiting for critical organs like kidneys, hearts, and livers that could save their lives. Unfortunately, there aren't nearly enough donor organs available to fill that demand. What if, instead of waiting, we could create brand new, customized organs from scratch? That's the idea behind bioprinting, a branch of regenerative medicine currently under development. We're not able to print complex organs just yet, but simpler tissues, including blood vessels and tubes responsible for nutrient and waste exchange, are already in our grasp. Bioprinting is a biological cousin of 3D printing, a technique that deposits layers of material on top of each other to construct a three-dimensional object, one slice at a time. Instead of starting with metal, plastic, or ceramic, a 3D printer for organs and tissues uses bio-ink, a printable material
Whoa.
that contains living cells. The bulk of many bio-inks are water-rich molecules.
That's really cool. That's
Yeah, I've never heard that term.
what do you call it? Bioprints?
Bio ink.
Bio ink. The bulk
Yeah.
of bio inks are water-rich molecules called hydrogels. Okay,
Dude,
so
that's our boy Tesh. Tesh, you worked with hydrogels.
yes, he did. It's like I'm thinking like it's all has to do with the extracellular matrix and like
Must be.
yeah. Yeah, that's really cool. Let's keep watching.
Molecules called hydrogels. Mixed into those are millions of living cells, as well as various chemicals that encourage cells to communicate and grow. Some bioinks include a single type of cell, while others combine several different kinds to produce more complex structures. Let's say you want to print a meniscus, which is a piece of cartilage in the knee that keeps the shin bone and thigh bone from grinding against each other. It's made up of cells called chondrocytes, and you'll need a healthy supply of them for your bioink. These cells can come from donors whose cell lines are replicated in a lab, or they might originate from a patient's own tissue to create a personalized meniscus less likely to be rejected by their body.
And I think this is a cool point to say, like, we're talking about 3D printing human tissue and bioprinting and bioinks, but this will eventually be a huge market in regenerative medicine from the business side of how can we store these cells of people like we do it like umbilical cord blood banks or blood banks and utilize their tissue later down the line if somebody does tear their meniscus or they have, a deterioration of their joints. You're able to take these out, thaw them, implement them, and then put them back in rather than just doing PRP. I think that's pretty cool.
Yeah.
There are several printing techniques, and the most popular is extrusion-based bioprinting. In this, bioink gets loaded into a printing chamber and pushed through a round nozzle attached to a print head. It emerges from a nozzle that's rarely wider than 400 microns in diameter and can produce a continuous filament roughly the thickness of a human fingernail. A computerized image or file guides the placement of the strands, either onto a flat surface or into a liquid bath that'll help hold the structure in place until it stabilizes. These printers are fast, producing the meniscus in about half an hour, one thin strand at a time. After printing, some bioinks will stiffen immediately. Others need UV light or an additional chemical or physical process to stabilize the structure. If the printing process is successful, the cells in the synthetic tissue will begin to behave the same way cells do in real tissue, signaling to each other, exchanging nutrients, and multiplying. We can already print relatively simple structures like this meniscus. Bioprinted bladders have also been successfully implanted, and printed tissue has promoted facial nerve regeneration in rats. Researchers have created lung tissue, skin, and cartilage, as well as miniature semi-functional versions of kidneys, livers, and hearts. However, replicating the complex biochemical environment of a major organ is a steep challenge. Extrusion-based bioprinting may destroy a significant percentage of cells in the ink if the nozzle is too small, or if the printing pressure is too high. One of the most formidable challenges is how to supply oxygen and nutrients to all the cells in a full-size organ. That's why the greatest successes so far have been with structures that are flat or hollow, and why researchers are busy developing ways to incorporate blood vessels into bioprinted tissue. There's tremendous potential to use bioprinting to save lives and advance our understanding of how our organs function in the first place. And the technology opens up a dizzying array of possibilities, such as printing tissues with embedded electronics. Could we one day engineer organs that exceed current human capability, or give ourselves features like unburnable skin? How long might we extend human life by printing and replacing our organs? And exactly who and what will have access to this technology and its incredible output? For more mind-blowing medical advancements, check out.
Hold on.
Check out.
That was actually crazy.
Yeah, that was really
wait.
cool. Going back to
A little bit, yeah, there. Right before there.
Such as printing tissues with embedded electronics.
That is so cool.
Wait a second, dude. Wow, I didn't even think of that. Like maybe that could even be possible. Duh, because if people are making
Like pacemakers.
chips on organs, not organ on a chip, but chip on an organ, you can literally bioprint that organ with the chip already embedded in it. Oh my God.
Pretty freaking wild.
Wow. That's amazing.
Yeah, that's cool. That's probably really far away, but still
Who knows
super.
though? AI and everything and like there's always something. I feel like by the time we're 50, 2050, that's gonna be like, wow, humanity's gonna be unrecognizable. you know, the internet was created literally like 24 years ago, 25 years ago. So I mean,
Yeah,
Google
that's
is
true.
it's just crazy. I mean, this is insane.
Yeah, the embedded electronics is super, super cool. Like that could fix, I don't know, that
Like,
could
you know,
fix diabetes. Like you don't need to fix the beta islet cells. You just need to put in a piece of a pancreas that's able to just secrete when the chip notices something in the body. I don't know. Maybe there's a small sensor in your mouth that detects how much glucose you're eating, and it's able to take samples and be like, okay, this is how much we need to release at this amount of time. That'd be cool.
yeah,
That'd be neat. But
I mean, any like the possibilities are endless. It could even go farther than just like your commercial applications. It can be like, or not your commercial, sorry, your your needed applications of like d diseases. It can go to the point of like, you know, like Hollywood level, like LA stuff where people are changing color of the eye based on their phone. From their phone, they
yeah,
can just change the color of their eye or, you know, do things that consumers want rather than need.
I think 3D printing an eye would be hard.
Super, but
All right. Yeah. What an
3D
interesting.
printing, you could 3D print only the part of the eye that is responsible for the color and then embed a chip in it. So it's connected to your phone and it can change whenever you want it, you know?
The
Like
eye. Yeah. Maybe. That's kind of nuts.
that is nuts.
Wow. All right. Well, that was a great video. Go check
Yeah.
out TED stuff, and they always make these TED Ed talks or these TEDx or yeah, these TED Ed talks are really really great. All right, Heem, I'm gonna stop sharing.
Yeah. Hopefully we can connect with somebody who does like actual 3D printing organ stuff because I would be like really interested
Yeah,
like
I want to learn about
in
like
some
just
stuff.
like the process of it. Like how do they even make the hydrogel and implement the cells and then load it and put it like it has to be a very, very technical process to make sure that you're not injuring any of the cells or messing any of the pH up or anything.
Yeah.
Yeah. All right. Well, you mean anything else?
That's all for me, man.
All right. Well, we hope you guys enjoyed this TED Ed talk or this TED Ed video. Heem and I definitely learned a lot. So yeah. This has been another episode of Cells to Tell. My name is Nick and the team, and we'll see you next time.
Yeah.